Yes, hi everyone, and welcome again to another math blog episode. And you might be wondering, why am I just math blogging? Well, to be honest, I can say and I strongly believe that there are more math experts and math scholars that are more credible than me. Those math experts who can lead and teach with much more moral leadership. Formal educational institutions are sanctuaries for moral leadership to happen, with the intent of cultivating talents and graduates who can make a difference for nation building. So let this blog be an inspiration and a conversation starter on the topic of moral leadership. You might say, oh, another noise in social media. Risk accepted, it's okay. The vow of poverty, chastity, and obedience that we can emulate from the examples of the priests, nuns, and the religious can really be a sanctuary of refuge. The big whys and the sincere intent of living out moral leadership can be traced back to the personal upbringing and past. And yes, the church is indeed a hospital of sinners. And yes, I believe that each one of us has a conscience and the natural character of a moral leader. Why is the moral leadership of the church and academic institutions very important to us? The church and academic institutions are our societal partners in shaping our character towards healthy choices and decisions that would shape a healthy community. And yes, let us continue to help each other shape our moral leadership, because as a member of a church, of a hospital of sinners, we all deserve the peace and the joy from the graces of doing what is morally right. So please find in the video description the links of some articles about moral leadership. And having math and science as a heritage that lives on, which has the language of the same moral leadership, okay, for a healthy planet and a healthy global family, let me share another piece of a math blog. Yeah, hi everyone, and welcome to this math blog episode. This is Man again, and in this episode we'll be talking about circles, how to derive its standard form of equation, and how we would be able to identify if an equation is an equation of a circle. On a side note, I want to ask you all to help me welcome a new lead of my plan. Okay, so it's nice to have the company of a plan. Okay, so going back to our topic again, it's about the circles. So let's start with this build. Okay, this is the build of Jose Marie M. Calamna. Okay, and he has some questions in this build. Okay, so let's use his build. Okay, so he's asking us to rotate B. Okay, so let's rotate it. Alright, so what did we just form? It's a circle. Okay, and then what is the radius of the circle? So that's the hypotenuse. It's 5. Radius is 5. And now that we just use this figure here, okay, and we have established a circle from the hypotenuse r, or the radius r, equal to 5. And yes, in a unit circle, we all know that we have a right triangle, okay, with the hypotenuse as the radius. Now, the question of Jose here, what is then the equation that would describe the relationship of the x, the y, and the radius. And the answer for that would be the Pythagorean theorem, of course. Okay, so that would be x squared plus y squared is equal to r squared, and in this case, since the radius is 5, so that's 5 squared. Okay, and the next question here is now telling or asking us what will be the general blueprint or the general form, the standard form of equation for a circle. As you can see, we can actually move the center of the circle, okay, like this. So the center is not in the origin, but above the origin or below the origin, right? So let's move to this another beautiful build. This is by Team, okay? And yes, he's saying us that the blueprint equation of a circle is x minus h squared plus y minus k squared equals r squared. And what is h and k? What do you think? Okay, yeah, we ended at the scenario where we move the center of the circle from the origin to somewhere above the origin and below the origin. So yes, h and k pertains to the coordinates of the center of the circle. So in this case, h is 0 and k is 0. So we are, as the center is in the origin, so we have this equation for the displayed circle. Okay, h is 0, k is 0, so the equation of this circle is x squared plus y squared is equal to 16 because our radius is 4. So 4 squared is 16. So we have some sliders here. So if we have a positive movement for the x coordinate of the center, so positive movement, then our h is 6, so that would the first term of the equation is x minus h, so we just substitute h with 6, so x minus 6 squared is the first term. Okay, and now we're going to move the center of the circle positively to the north or above the origin. So our k is 4, so we just have to substitute 4 to the k of the blueprint equation. Okay, so the first term remain as it is, okay, because our x coordinate of the center is 6 and our y coordinate of the center is 4. So we have this equation for the displayed circle. Okay, so again, if we have positive values for the coordinates of the center of the circle, then you will have negative or subtraction, okay, in these two terms here. Okay, and now if we will be considering negative values for your x and y coordinates of the center, so we will move the center negatively. Okay, alright, so that would be at the left side of the origin. So as you can see here, our x coordinate is -6, and we will be moving again the circle negatively, okay, or under the origin. Okay, so we have -5 as the y coordinate of the circle. So again, the x and the y coordinate of the center of the circle are all negatives. So we will be having addition or plus signs in these terms, because when you have the negative beside a negative, it will result to a positive sign. So you might, in at one glance say that you have positive sign, so it pertains to positive x and y coordinates for the center, but it's the opposite, okay? Because our blueprint or the standard configuration of a circle is this one: x minus h squared plus y minus k squared is equal to r squared. And now it's storytelling time. Let's go back to the time of the early civilization at Levant and at Mesopotamia. So when we talk about Levant, so these are the places that we're referring to: Syria, Jordan, Israel, and the other states here. And we also have Mesopotamia, the land between rivers. We all know that early civilization happened at places where there is water system. And why are we talking about Mesopotamia and Levant? Because this is here where we can trace the ancient application of the symmetrical properties of a circle. Okay, so we have the potter's wheel. You might be thinking it's the wheel for transportation, but no, it's really the potter's wheel. Okay, and if we will be digging into Mesopotamia, then we can have these artifacts. Okay, artifacts on the wheels for transportation. And yes, we can see in this Smithsonian Magazine article the statement that no wheels exist in nature, which means that the invention of the wheels is 100% Homo sapien. So what comes close though to the symmetrical properties of circle in nature? We have the flagella, the dung beetles, and the tumbleweeds. But again, no wheels 100% exist in nature. And moving forward, I'll be showing you some images, okay, on how the symmetrical properties of circle been applied or being used. So if you have a athletic track in a circular form, if you have parks, okay, and of course here in Cebu we have the rotonda, the puente circle, the Osmeña circle, and you can also have buildings, okay, inspired from the symmetrical properties of a circle. And again, you have rotondas, and of course practical use. Okay, the practical use of the symmetrical properties of a circle can be found in the circular cylinders, okay, that you can see in a printing press, okay, in the traditional way of printing newspapers. So we have circular cylinders here. So I hope that you like this math vlog, and I'll be producing more for all of you, and please do support my YouTube channel. Click on like, subscribe, and share this to your friends. So let's continue appreciating some heritage assets and math with the help of GeoGebra, and I'll make sure to research some articles related to the topics that I'll be presenting in this channel. So thanks again, and I'll see you in my next vlog.